Rational expressions and equations, part 1. A rational expression is an expression that can be written as a ratio of two polynomials. Of course, such a fraction is undefined for any values of the variable for which q equals 0. That means the denominator can't be 0. A given rational expression is simplified or reduced when p and q contain no common factors other than 1 and -1. In other words, what you need to do whenever you're trying to simplify a rational expression is make sure everything is completely factored, reduce everything that can be reduced to 1, and then your fraction is completely simplified. So look at this numerator. This is the sum of cubes. To factor a sum of cubes, to get the x cubed, you have to cube x. Since that's a plus, this is a plus. To get 27, you cube 3. Now, since this is a plus, this will be a minus, and this one is always a plus. You square the x, you square the 3, and in the middle you multiply them together. Okay, so we have factored the sum of cubes. In the denominator, we can factor out the greatest common factor, which is x. And we'll be left with x plus 3. Now, x plus 3 is a factor, and all of this is a factor because these two are multiplied by each other. Same thing here. The x is a factor, and the x plus 3 is a factor. So whenever you have x plus 3 over x plus 3, they reduce to 1. You'll be left with x squared minus 3x plus 9 all over x. Keep in mind that those x's can't be crossed off because these are not factors. They are terms. They're either subtracted or added to each other. For you to be able to cross them off, they need to all be multiplied. Okay, have a look at B. The numerator is a trinomial. It's quadratic. It can be factored. Factors of -18 that add up to 7 will be a +9 and a -2. Now in the denominator we almost have x minus 2. The problem is it's written backwards. So just to remind you of something, what if you had -1 times 2 minus x? That would be -2 plus x, which is the same thing as x minus 2, right? So what I want to do is factor a -1 out of the denominator, and I'll be left with x minus 2. I did that because now I can reduce these. So I'm left with x plus 9 over -1. You can also write that as a -x minus 9. Remember that only common factors can be canceled. That's what I was alluding to on the previous screen. Since the x and the 4 are not multiplied together, they're not factors, which means these x's cannot be reduced. So that particular expression is already completely reduced. Okay, let's have a look at subtracting these things. Well, in this numerator, it's already in completely factored form, so I'm just going to write it like it is. The denominator, we can factor that one into factors of 8 that add up to a -6 would be a -2 and a -4. And this denominator is difference of squares, so we can factor it into x plus 4, x minus 4. Now if you remember how to add fractions, let's review for just a moment. If you had something like 1/2 plus 2/3, or let's say minus 2/3, since my plus didn't work anyway. Remember, you need common denominators, so 6 would be your least common denominator. What do you multiply by 2 to get 6? You multiply it by 3. Do the same thing to the top, and 1 times 3 is 3. Well, what do you multiply by 3 to get 6? Okay, so multiply the numerator by the same thing. And then 3 6 minus 4 6 is -1 6. Well, you want to use the same idea, but with these really big fractions. Your least common denominator would be one of each of those factors. So you're going to need an x minus 2, you're going to need an x minus 4, and an x plus 4. So what do you have to multiply by this denominator to get this denominator? You need an x plus 4, right? That's what's missing. Well, here, remember, that's the whole thing is multiplied by whatever you do to the bottom, you have to do to the top. So this becomes that. Okay? Now over here, what are you missing? What do you multiply by this denominator to get this one? You need an x minus 2. So you multiply this by the same thing. So you end up with minus 2x times x minus 2. Now be careful, you don't want to start crossing stuff off because there's a minus right here. So now what you need to do is multiply everything out. Well, not the denominator. Multiply everything out in the numerator. So we're going to get 3x squared plus 12x minus 2x minus 8 minus 2x squared plus 4x. And it's all over that denominator. I don't have enough room, so I'm just going to go ahead and simplify the numerator, if that's okay. So we're going to have 3x squared minus 2x squared, that's 1x squared. 12x minus 2x is 10x, and 10 plus 4 would give us a 14x. And then we just have a minus 8 left over. And that's all over that denominator. So will the numerator factor anymore? Are there factors of negative 8 that add up to 14? There aren't any, so that means this is as simplified as this expression will be. Okay, let's have a look at this problem. Here we have to add and subtract fractions, so we do need to make sure everything is completely factored first. Okay, in the second fraction, the numerator will factor factors of negative 6 that add up to negative 1 will be a negative 3 and a positive 2. And in the denominator, factors of negative 10 that add up to a negative 3 will be a 2 and a 5, where the 5 is negative. And then in the last fraction, in the numerator, you need factors of negative 20 that add up to 3. There aren't any, so we just write that one down like it is. And in the denominator, we have difference of squares, and that will factor into x plus 5 and x minus 5. Now have a look at your second fraction. We do have everything completely factored, which means x plus 2 over x plus 2 is 1. So now we have x plus 4 over x plus 5 plus x minus 3 over x minus 5 minus all of this fraction. So your least common denominator is going to be x plus 5 and x minus 5. Okay? So here, you're missing the x minus 5, right? So whatever you multiply by the bottom, you have to multiply by the top. So you're going to have that x plus 4 times whatever's missing, which is x minus 5. Do the same thing for the second fraction. You're going to have the x minus 3, because it's there, times what's missing here, the x plus 5. Then you're going to have minus all of this times whatever's missing here. But there isn't anything missing. So we just subtract all of this. Excuse me, I keep having to clear my throat. Okay, in the numerator, multiply this out. I'm going to do this on the scratch paper since I'm running out of room. So we're going to have x plus 4 times x minus 5. That will be x squared minus 5x plus 4x minus 20. Combine your like terms, so x squared minus x minus 20. Okay, now we have x minus 3 times x plus 5. That would give us x squared plus 5x minus 3x minus 15. Combine your like terms, so x squared plus 2x minus 15. And that's a plus, so we just bring it all down. Okay, now we have to distribute this negative, so we have negative x squared minus 3x plus 20. Keep in mind that's all over the denominator, but I'm running out of room, so we'll just work with the numerator for now. Let's simplify. X squared minus x squared is 0. Negative 20 plus 20 is 0. So it looks like we're going to be left with this x squared. And here's a negative x plus 2x. That's going to be x minus 3x is a minus 2x. And the only thing left is a negative 15. Let's go ahead and factor that. Keep in mind we're still working with the numerator. Factors of negative 15 that add up to a negative 2. That'll be a 3 and 5 where the 5 is negative. So you end up with x plus 3, x minus 5, all over x plus 5, x minus 5. Well, now the x minus 5s can be reduced. So you're left with x plus 3 all over x plus 5. That was so much fun, wasn't it?